today I'm going to teach you about Unit 5 isometric projections, okay, in which you will be learning 2D conversion to 3D and 3D conversion to 2D. 2D is two-dimensional conversion. The 2D figure can be converted into three-dimensional figure. If a three-dimensional figure is given, how will you convert to 2D dimension? We will be learning that from today's topic, okay. So the Unit 5 topic, isometric projections. Okay, now in this topic there are three important points which you have got to remember. First point, as we have already discussed in isometric projections unit 4, it is isometric scale. Okay, in which we will be drawing isometric scale with the help of OA line, OB line and OC line. OB line is drawn at an angle of 30 degrees and OC line is drawn at an angle of 45 degrees with the baseline of OA. Okay, and then in this again we have isometric axis. Three axis, x-axis, y-axis and z-axis. On x-axis we will always mark maximum length. On y-axis we will always mark height. And on z-axis we will always mark width. Okay, if the observer's position is given on x-axis, we will keep the observer's position in x-axis only. If the observer's position is given in z-axis, we will keep the observer's position in z-axis also. Okay, if it is not given, we will default take the position of the observer where the maximum length is, which is x-axis. Clear? And the third point is the most important point which you have got to understand in isometric projections when you are doing the conversion from 2D to 3D and then 3D to 2D. When you are doing conversion from 2D to 3D and then 3D to 2D, this is the topic which is there in isometric projections unit 5. Okay, so the most important points, like the figure will be given to you. If the 2D image is given, it will be in this format. Okay, you might all wonder what those boxes are. Okay, now as we all know, the first quadrant, when we have a reference line, xy line, above we will have vertical plane and below we have horizontal plane. The front view is in vertical plane and the top view is in horizontal plane. So we'll always have front view above top view. Top view will always be below front view. So this is the understanding from the boxes here. Okay. Now the first box, because I've already explained you the front view and top view, it is easy to mark. Okay. In this case, which one you'll mark as front view and top view? The only hint, the first hint we have to take it is, whenever there are boxes side by side, whenever there are boxes side by side, it is understood that particular box is the front view box. If you have any boxes side by side, the middle box will be always considered as front view box, and below front view box it is taken granted that it is a top view, because the projection of all front view views will fall on top view. So all lines will coincide with each other. The projection of front view is your top view. Now if we consider this as a front view, okay, so this becomes top. Now as you can see here, the box is on the left hand side. To see anything on the left hand side, you have to view from the right side. To view anything on the left hand side, you have to view from the right side. To view anything on the right hand side, you have to view from the left hand side. Okay, so now as the box is on the left hand side, the view is from right side. So you write this as right side view, or else left hand side. Okay, now this is the left side view or right side view. Okay. Now, as you can see here, the box is up and the box is below. I'm going to write here as top view and front view, because the two boxes are in the middle. Which one will consider it as front view box? Okay. So now the side views will come only for front view. Always remember, side views will come only for front view. You won't get the side views for top view. Okay. Now this is left hand side and this is right hand side. Okay, so this is for right side view, we have to look from left side. So this is right side view, and this is left side view. Now in this case we have a middle box and the top box and the two side boxes. In this kind of problems, this will be your front view and this will be your top view and this will be your side view. Okay, this is your left side view and this is your right side view. Clear? This is your left side view and this is your right side view. Clear? Now, if this is how the arrangement of questions will be given from 2D to 3D. These boxes are useful for 2D to 3D. Now, the labor hint. The labor hint which you have got to remember when you are doing the problems is, okay, if your given problem has L shape, if your given problem has L shape, any kind of 3D image or 2D image has L shape like this, okay. Now, all you have got to do is keep your hands on those L shapes and that will help you out in drawing the measurements on which axis, okay. Now, if you keep your left hand here, the L shape is in this direction. So, you will be measuring, marking this dimension. You will be marking this dimension on Z axis. And observer's position is here. If you keep your right hand, if the given drawing has L shape on the right hand, if the given drawing has L shape on the right hand, okay, like this, then this dimension will be drawn on X axis. And the observer's position is here. This is the biggest hint when you people are doing the drawing to analyze the given question. Okay. If L shape is on left hand side, the maximum length will be marked on Z axis. If L shape is on right hand side, the maximum length will be drawn on X axis. For example, I'll give you the problem and that will help you out to understand on which axis you're supposed to start your problem. Okay. First problem, this is 2D to 3D conversion. Okay. This is 2D to 3D conversion. So the first problem is this measurement is given as 40 mm. Okay, and this measurement is given as 30 mm. Okay, not 12, 30 mm. Okay, and this measurement is given as 15 mm. And this measurement is given as 20 mm. Okay, and this measurement is given as 30 mm again. Okay. Okay, and then now you project all these points down like this. This is your front view. And then you will draw a rectangle. Okay. And then you drag this line. This is your top. And this measurement is also 40 mm. Okay. And this is 10 mm. And this overall measurement is 7. The length, the common. Okay. So now in this, the lines which are going to be dark are, this is the front view. Okay, as you can see, I have projected all the lines down. So now, as you can see here, the height of the front view is given as 40. The length of the front view is given as 70, and then there is this distance given as 30, this distance given as 30, and this is 20, and this is 50. These are the dimensions given in the front view. And in the top view, again this is given as 40, and the maximum length is given as 70, and this is 10. Okay, now based on this is a two-dimensional image. It has got only length and height. This is a two-dimensional image. Now how will you convert this two-dimensional into three-dimensional? As usual, first we will check all the values here. The values are 50, 20, 30, 40, 70 and 10. Yes? So all I have to do here is, first I have to draw the isometric scale. OA line, 30 degrees OB line, and 45 degrees OC line. Okay? 30 degrees OB line, 45 degrees OC line. Clear? And then the values are from 5 till 70. The maximum value is 70. I'll mark those points on OC line with the help of normal centimeter scale. So it is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay, it is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 7. Clear? And then I'll project all perpendicular lines to OA line, which will coincide the OB line. And we know OB line is the isometric length, and OC line is the true length or actual length. Clear? Now, to start the drawing with, the axes of the three dimensions are x-axis, y-axis and z-axis. X-axis is drawn at an angle of 30 degrees, y-axis is drawn at an angle of 90 degrees, z-axis is drawn at an angle of 30 degrees. Clear? Now, the measurement, now as first thing, see here, this is front view and this is top view. This is front view and this is top view. A line in the middle is XY line, the reference line. Okay? Now, the maximum length is 70. The L shape of the drawing is on right hand side. The L shape of the drawing is on right hand side. So you will be marking this measurement of 70 on x-axis if the drawing has front view and top view. Two boxes which I drew earlier, the hint box, the third point. Okay? Now, the L shape is on right hand side. So you mark this 70 value on x-axis. So you have what? Isometric view. So I'll measure 70 from 0 to C. Okay? I'll measure 70 from that line, and from here I'll mark that distance 70 here. Okay? I'll measure this from the OC line, and from here I'll cut the arc for 70. As I've drawn this line here now. Okay? Very good. Now from here I'll be measuring 40 mm. I'll be measuring 40 mm. I'll measure 40 from there, and from there I'll cut the arc, and then I'll draw 40 mm line which is parallel to y-axis, which is parallel to y-axis. Okay? And then I have a continuation of 30 mm. I have a continuation of 30 mm. and this 30 mm value is parallel to 70 mm. So whatever values I have parallel to 70 mm, all those values I will draw parallel to x-axis only. Whatever values I have parallel to 70 mm, all those values I will draw parallel to x-axis only. Whatever values I have parallel to 40 in the front view, all those values I will mark parallel to y-axis. All those values I will mark parallel to y-axis. So I will be using only x-axis and y-axis here. In the front view, I will be using only x-axis and y-axis. So 70, 30 and 30 will be marked on x-axis, parallel to x-axis. 40, 20 and 15 will be marked parallel to y-axis. Clear? This is your x-axis and this is your y-axis height because it's a front view. Now, after I'm done with that, I'll measure this 30 from the OC line like this and then mark that value parallel to x-axis. Parallel to x-axis. And then I'll project the line parallel to y-axis because I don't know this distance. I don't know this distance. And then when I come to the other end of the drawing is here. So from here the measurement is given as 15. The other end of the drawing is 15 height. Okay, here it is 40, here it is 15. So from here I'll measure 15 like this. Okay, and then I'll draw another line parallel to x-axis because I don't know this measurement as well. So I'll draw another line parallel to x-axis and the line parallel to x-axis. Clear? Okay. So I'm done with the cell shape of here. Yes? Okay. Now all I've got to do is I have to come down to the top view now. Top view, the width is given as z-axis. For top view, the axis we will be considering are x-axis and z-axis. For the top view, we will be considering x-axis and z-axis, the width axis. So x-axis 70 is already marked. The continuation is width. This is width. So this is z-axis. So from here, I'll mark 40 like this. Okay. And then I'll dark this line. So whatever end I have 15 here, the same height I'll measure 15 here also. And then complete the 40 mm line parallel to z-axis. Clear? And after that, the same measurement I'll be using here also. From here it is 40 mm again. The width is given as 40 mm which is parallel to z-axis. Parallel to z-axis. This line is parallel to z-axis. The same 30 mm line. This line I'll draw parallel to x-axis. X-axis, x-axis, x-axis. Same 30 mm. And then again I'll draw the 40 mm line parallel to z-axis. I've drawn 40 here and then height 50 and then again 40 and then keeping this line as parallel from here I've drawn 40. Okay. And then I've drawn 40 and then 30, 30 parallel to x-axis. Clear? Again, I'll take this measurement. And I'll draw the line parallel to y-axis based on this height. I'll take this measurement and then I'll draw a line parallel to y-axis with the same measurement. And then I'll draw another line parallel to this box, to this line. Okay? With the same measurement, I'll complete the line. And then again I'll draw another line like this, which is parallel to z-axis. Clear? Now, height of the box is given as 20 here. I'll mark the center point here on this line. Okay? And then I have to measure how much? 20. What is the width of this? 10. So from here I'll mark 5 and 5, which is 10. Okay? The height of that line is 20. So I'll mark 20, 10, z-axis parallel to z-axis. 10 is parallel to 40, z-axis. And then I'll mark same 20 here. The length of that box is given as 30. So from here I'll measure 30, I'll measure 30, I'll measure 30. Okay? And then I'll complete 10 here and 10 here. And then 20 height there. And then 10 here and then 20 height there. Okay? So this completes the of the given drawing. Okay. Now these are the only lines which are dark here. Okay. Clear? Okay. Now if you observe this, the observer's position is on the maximum length 70 value. So I have kept the observer's position here. When the observer is viewing from here, you could see this whole L shape. Yes? So this is your whole L shape, the front view. Clear? And then when the observer is seeing, he could see only this rectangle of 30 and 20. 20 and 30. This rectangle. This is number 1 and this is number 2. So this is 1 and this is 2. The complete L shape is 1 and this rectangle is 2 from the front view. When you see from the top, the whole complete rectangle is visible to you, which is 70, right? So this is 70 complete and the width is 40. This is also visible from the top view. From the top view, when you see, you could see this 40 length and width, and you could see 70 length of the box. So you'll have this 40, 70 and 40. Complete the rectangle there. So when you see from the top, you see this area. This area is third area and this is the third area. Okay? When you see from the top, you could see this rectangle which is 30 and 40. Which is 30 and 40. This rectangle is third area. And then this area is visible to us. This is the fourth area. So this is the fourth area, which is 30 and 10. 30 and 10. So as you can see, the 2D image is converted into 3D image. Okay. In the front view, we will be using x-axis and y-axis. In the top view, we will be using x-axis and z-axis. X-axis and z-axis. Clear? Now the next problem we